Hello, class, the receiving students and teachers.
Hello, Mrs.
You may be seated. Class, the receiving students, I'd like us to recall back to our previous lessons, the first two lessons on pulleys that we had. We had a look at a single pulley and also a double pulley. Now, a single pulley helps us to lift loads up by pulling whatever we are using, whether if you are using only your hands to pull or a force meter, which is a spring balance. Now, on a single pulley, we only have two ropes. We have rope A that holds onto the holds onto the load, and we have rope B that is attached to the spring balance, which is the force meter. Now, the work done on the load on a single pulley is less than the work done by effort on a single pulley. Now, this is because we have one rope that is holding up the weight or the load. On a double pulley, we have three ropes. We have three ropes, rope A, B, and C. Now, if we look closely, we can see that rope A and B are helping to hold the load. And that is why the effort or the work done by the effort is less than the work that is done by effort on a single pulley. Now we are still on the same strand, same substrand, and same outcome. Our lesson topic for today is still on pulley. It's the third lesson on pulleys. Now in this lesson, students and teachers, we will be measuring the work done on a load by the machine and the work done by effort, which is the effort that you put in by pulling down the force meter to find out the work that is done by that effort. Now, we will be going through once again the same steps that we have used in the first and the second lessons. And I'd like us to go through again, so please, class and the receiving students, take notes. So if you were not able to follow those steps well in the first two lessons, you should be able to do that better in this lesson. Now, before we go, our teachers, the strategy is group work. Students will be working in their groups. Our first step is to set up the apparatus, as shown in the first lesson that we had on pulleys. Now, second is to put a mark on the retort stand, 15 centimeters above the base of the stand. In the first two lessons, we used 10 centimeters, which is equals to 0.1 meter. This time, we are going to be using 15 centimeters. If I can have Adrian to tell us, when you convert the 15 centimeters, what should you have in meters?
.15 meters.
0.15 meters. So this time, students in the receiving schools, we will be using 15 centimeters or 0.1 meter to start off our activity for this morning. Now, 3 is to take the mark of the load and the effort distance at start when you are beginning your activity. 4, You slowly pull down the spring balance to lift the load until the bottom of the load is level with the 15 centimeter mark on the retort stand, not 10 centimeter as of those first two lessons we had. 5, or the step 5, you are to measure 1, the reading on the spring balance, that is the effort needed in Newton, and 2, distance the spring balance moves, that is to find the distance moved by the effort. Now 6, you are to record your readings in the table for effort needed, that's 1, and 2, distance moved by the effort. 7, you are to calculate the work done, and don't forget our lesson today is going to be on calculating work done on the load by the machine. The machine that we are using is the pulley, and also work done by the effort that you put in getting that force meter to help you to get the load to be lifted up. Now, and you are to use again the formula work equals force times distance, and your answer must be in meters. Now, I'd like us to have a look at the table. Teachers in the receiving schools, that is how the activity table should look like for your students to do that activity. We have 4 different gram loads that are in grams for the students to use, and that every group is going to be working on different loads. Now, for you to find the work done on the load, you will be using this part of the chart, or this part of the table. Now, your load is already there, and the distance moved by the load is already there. So you calculate that to find the work done on the load. Now, on the other side of the table, you have effort needed. You should all know how you should find that effort needed. Then you have the distance moved by the effort, and when you calculate these two together, that should give you the work done by the effort. Now, if I can have the runners from every group to come and get your apparatus that you are going to use. Don't get this, those 4 there. That load, group 1, 2, 3. Group 1, you will be on the 100 gram mass. Group 2, on the 200 gram mass. Group 3 on the 300 gram mass, and group 4 on the 500 gram mass. So the load that you get, check to see that you have the correct load with you. You are working together as a group, so the answer you get or the result you get should be the same. You should discuss what you get because you're all working together on the same apparatus to find your answers. Get somebody from your group. Once you finish, you have to have somebody from your group to present your results. When you finish, you have to have somebody from your group to present your results. Bobby, when you finish your what and you have answered this question, you have to have somebody from your group to present your results. Helen, just let your friends know. Once you finish, you have this question here. See? You have to compare that to answer the question and get somebody who to present your results. I can't. One, you're only to work on 300. Yeah? That's for the other groups to work on. Yours is 300. Show us how you got your answers. So, formula, just write the formula, they work. Work times, yeah, work equals force times distance. Okay, have one here and another one. There's 5 of them and I want all the answers up, so this I'm going to finish quickly. Okay, let's give them the answer in. Shane, I've already told Helen, you probably have to get somebody. Okay, and that person has to, when you are asked to present, you have to go and show on the whiteboard your formula. How did you get that work done by the load and also work done by the effort? How are you getting that answer? It must be shown. So get somebody. And 100, 200, 300, and 500. 400. Listen, Violet, that person that you appoint to present your work, that person has to show on the whiteboard how you got your work done by the load and work done by the effort. And then from there you compare, that's where you answer the question. So somebody that you appoint from your group must go through all that. Bobby, you already appointed someone to present your, okay, that person, you have to show on the whiteboard how you got your work done by the load and your work done by the effort. You have to show that. And then tell us, because of this, we say your answer for the 5th question. Sorry. Sit there. Hi, Anna, did you get someone from your group? Okay, listen. The person that you appoint from your group, you are going to show on the whiteboard. Okay. The formula, we already know the formula is there. Okay, you're going to show your friends how you got your answer. Now, in the previous lesson, we only gave our answers and went through it. This time, I want it shown on the whiteboard. How did you get your answer for work done by the load and work done by the effort? And then that gives the answer.
It's the work done. It's by the effort.
All finished. They all finished. Let's group one here. 100 gram mess. 200, 300, and 500. And it's 15 centimeter above the base of the stem. Because the two previous lessons we had it 10 centimeter that the distance was. But that's okay, leave it. Yeah, it's okay. Class and the receiving students, you have a question there, and that question is based on the experiment that you have just done. Which is bigger, the work done on the load by the machine, that is the pulley that you used, or work done by the effort you put in? Now, for presentation, teachers in the receiving schools and students, I will be having a student from every group. Now, we will have two from every group. One will record your results on the results table, and the other one will have you to show us on the whiteboard how you got your answers. So we will start with group one. Group one, who is on 100 gram mess or 100 gram load. Now there should be two, so we have one of you to go and write the, or otherwise let's save the person who is going to work out. You go and write your results quickly, come back and get your what done. From here. Okay. Okay, sorry, let's just have you to have your working out first. and then you can go and have your results done. Thank you, Linda from Group 1. Marker here. You just write out your working out here. Yeah, like how you got over there. If you can have your result on the table quickly. And we'll have group 2, please move. Now I'd like you to show, you already have the formula up there. But if you can just have force times distance. And you show your first one, your second one. And that can make it easier for us to see. If I can have group 2, please. Thank you, Tanabik. Thank you, Tanabik. Have it recorded there. Group 3. Yours is the second one, 200 gram mess. Record across. Thank you, Tanabik. Tanabik, go around the back. You go around the back. Thank you. Thank you, Messi. Last group, please. Group 4. You have to sit down. Thank you. Have your answer written. Thank you, Aquari. Okay, if I can have Sinavai, you can give us your answer, what your group had for which is bigger, the work done on the load or by the machine. Which is bigger, the work done on the load by the machine or work done by the effort you put in? What did you get, you and your friends?
Work done by effort is bigger than the work done on the load.
Okay, good, thank you. So that is what we should have all had. Now our summary, we have a short summary, it's only one. Work done by the effort is greater than work done on the load. Now let's have Patricia, she can give us a key phrase for this lesson.
Pulleys.
Pulleys. Okay, let's see what I have. Less work on load, more work on effort is a key phrase. Now our next lesson is going to be on other useful machines. Receiving students and the class, we had a previous lesson we had on the different types of simple machines. We will once again be having another lesson on other useful simple machines. Materials needed are pictures of simple machines and worksheets. And with that, class and the receiving students, thank you for your participation.